Hello guys, welcome back to Python Fundamentals episode 8. I am Aditya Thakur. Let's take stock of where you actually are right now because it's genuinely impressive amount of ground. You have mastered every core data type, every operator, real decision making with if and match case, loops of every kind, and last episode, list and tuples in full depth, which included creation, methods, comprehension, unpacking, and the works. That's 7 complete episodes of real working Python knowledge. But here's something worth noticing that every data structure we have covered so far organizes information by position. A list's first item, a tuple's second item, a string's third character. Position is how you have found things. Today that changes. We are covering dictionaries and sets that are two data structures that organize information by meaning instead of position, a name, a label, a unique value. This is genuinely a different way of thinking about data, and once it clicks, you'll realize how much of the real world doesn't have have a natural first, second, third order to begin with. That is a person's profile, a person's attribute, or a product's attribute, a configuration file. All of that is dictionaries. I want to be upfront that today is another long episode and deliberately so that dictionaries in particular are used constantly in real Python code, probably more than any other single data structure, besides list and tuple. Getting genuinely comfortable with them now will pay off in nearly every episode that follows. As always, code along with every example. Don't just watch, and when we hit the practice problems, actually attempt each one before I reveal the solution. There are 5 of them today spread across every section. Here's exactly what we are covering in order. First, key value pairs, then safely handling with missing keys and mutability. Second, the full dictionary method toolbox, which includes key values, items, then update, then pop, and a few methods you probably haven't seen yet. Then third, dictionary comprehensions, which include the same one-line shortcut idea from list comprehension, which we studied last episode, now applied to key value pairs, and finally, sets. A genuinely different structure built entirely around one guarantee. That is, every value inside it is unique. By the end of today, you will be able to represent real, structure meaningful data. It is not just order list of values, but actually codes with labeled fields. And you'll know exactly when reaching for a dictionary or a set is the right call instead of list. So let's get into it. Moving on to the first one is creating and accessing dictionaries. This is the first section of this video. See, Python's way of storing data as key values pair instead of ordering position is known as dictionary. Let's create your first dictionary. Let's type this out in our VS Code. Person equals curly braces, then name, Sam, then age, age 25, then city, then Mumbai. Now, let's print person. See what we got. Name, Sam, age 25, city, Mumbai. See, this creates a dictionary using curly braces with each entry written as key colon value separated by commas. Instead, unlike a list, you don't access items by their position in same sequence. You just access them by their key, by their meaning. Name isn't the first item, okay? It's specifically the thing labeled name, okay? Now let's move on to the next one. Next one is accessing values by keys. Let's understand this by performing this example. Person equals curly braces, then key is name, then value is Sam, age 25. Now let's print person name. Now print person age. See, what do you got? You got Sam, then 25. See, square brackets again, exactly like list indexing. Uh, that is, but this time containing it contains key, not a numeric position. This is the core conceptual difference between dictionary and everything we have covered up through episode 7. See, हम पहले जैसे लिस्ट में what we did in every episode before, what we did, we used numbers, ठीक है, indexing, we used indexing, but in dictionaries we are using the like the keys to identify the thing. Now let's move on to the next one. Next one is key error, accessing a key that doesn't exist. Let's see what happens when we access a key that doesn't exist. Let's try this one. Person name Sam, age 25. Then print person email. Let's see what happens. It will return a type error. See, wait, it will return type error. See, view type error. Ah. See, just like index error for list going which was going out of range back in episode 7, key error fires when you ask for a key that simply isn't in the dictionary. This is not type error. It's my mistake. It's key error. So this is genuinely the one of the most common errors you will be hitting while working with dictionary. Okay. Now let's move to the next one. Next one is the safer way, which is get. Let's try this one. Then we'll know the get. Person equals name Sam each. Now print person dot get email. Now print person dot get email. Then n slash a. Let's see what happens. Wait. See, we got none and none. See, get never raises a key error. If the key is missing, it returns none by default. Or if you provide a second argument, it returns that fallback value instead. This is generally the safer way to access a dictionary whenever you are not 100% certain that key exists or not. Just use get if you're not sure about that. Now, let's move to the next one. The next one is dictionaries are mutable. Let's check this one out and let's see if dictionaries are mutable or those are immutable. Person equals name, Sam, age 25, person, age equals 26. Oh, let's print the person. See, it could change. See, exactly like list from episode 7, dictionary can be changed after they are created. Assigning to an existing key with square brackets simply overrides its current value directly. Okay. Now let's move to the next one. Next one is adding a brand new key. Let's test this code first, then we'll see. Person equals name, then Sam, then age, then 25, person, email equals Sam @example.com. Let's suppose this is the email. Then let's print the dictionary person. See, it added a new key. See, that exact same square bracket assignment syntax also handles adding a completely new key. Okay, Python doesn't know doesn't Python doesn't need you to declare it in advance. It just creates the key automatically if it doesn't already exist. Okay. Now let's move to the next one. Next one is keys must be unique. Let's check this out and we'll find out if what happens when keys are not unique. Person equals name Sam, then name Alex. Now let's print person. See, here's uh here's a subtle one worth flagging. If you accidentally write the same key twice while creating a dictionary, Python doesn't throw an error, but it silently keeps only the last value assigned to that key. So dictionary ends up with just one entry, which was name is Alex. Sam quietly disappears. Worth watching for, especially in larger dictionaries where duplicate keys might not be obvious at the glance. It's very useful. So what we learn from here is when you when they are same keys, then it will return the last value of that key, like the last one. Now let's move on to the next one. Next one is checking if a key exists or not. Let's see how can we check if a key exists. Person equals name Sam, comma age 25, then print name in person. So basically we are using in to find if it exists or not. Just write in. INN. Email, in person. Let's see what Boolean value we get. See, first we got true, then we got false. See, in the this in checks against the keys of dictionary by default. This is generally the safest pattern for avoiding a key error. This checks just check first with in, then across, rather than risking the error. Now let's move on to the next one. Here comes the practice round first. Just pause the video and try this, and then you can after that you can just resume the video and check the answer. What's the question? Create a dictionary representing a book with keys, title, author, year. Print the title using square braces. Safely try to access a genre key using get with a fallback of unknown. Add a new key, cold pages with a number value. Let's try this out. Then let's see what we get. Book equals title, Dune, comma, author. Then what was the author name? Frank Her Herbert Hubbard. Uh, After that, what was asked? Year was 1965. 1965. Now let's print book title. Oh, wait. Now then print book dot get genre unknown. Now book pages equals 412. Now let's see what we get. See, we got the Dune unknown. See, get function with a fallback completely avoids a key error for missing genre keys. Printing unknown instead of crashing, and square bracket pages is equal to 412 shows exactly how easily new keys get added on the fly. Here, no special syntax needed beyond what you're used to update an existing line. Okay. Now let's check the answer. See, if you can check the answer over here. Book is equal to title, Leon Frank Hubbard. Year 1965, print book title, then print book dot get genre unknown. Now let's move to the next one. Here comes the section 2 of today's video, which is dictionary methods. Uh, Here we'll learn about dictionary method toolbox, which includes reading, updating, and removing data. Let's move to the next one. Here is the first one, which is keys. Here we are learning about keys. Let's try the code. Let's see how we get key. As usual, person is equals to name, Sam, age 25, uh, print person dot keys. Now for key in person, print Key. Print person. See, we got name and age. See, keys return a view containing every keys in the dictionary. You'll most often see it used directly inside a for loop. Okay, exactly like this. Exactly like this. To process every key one at a time. This is used. Now let's move on to the next one. Next one is value. Getting every value. Let's see how we can get the values. Let's try this code. Person equals name, then Sam, uh, age 25. Now print person dot value, values, not value. Now for value in person dot values. Now print करेंगे हम value को. Oh, let's print this. See, we got the values Sam and 25. See, the natural counterpart to keys is when you only care about the values themselves, and you generally don't need to know which key each one belongs to. Then we use the values when we want the value only. Here we use dot values. Now let's move on to the next one. The next one is items, getting key and value together. Let's see. Let's just test this code only. Wait, let me just copy this. Control C, Control V. Now for key comma value in person dot items, here we'll print key comma value. See, we got both keys and values. See, this prints name Sam, then age, which is 25. This is generally the most common way you'll loop over a dictionary in real code. See, items give you both the key and the value together, unpacked directly. Exactly like unpacking a tuple, which we covered back in episode 4. Now, let's move to the next one. Next one is update. Here we can merge dictionaries by using update. Let's test this code. Person dot update age. It is inside the string, comma city, then print. See, update merges a second dictionary into the first one, and keys that already exist get their values overwritten with the new ones. Age goes from 25 to 26, and any brand new keys like city here simply gets added into it. See what happened. City got added, and age was converted from 25 to 26. Now let's move to the next one. Next one is pop. It is removing by a key. Let's test this one out. Person equals name Sam, age 25, removed age equals person dot pop age. Now print removed age and now print person. See, here we got only name, which is Sam. See, exactly like the list version of Pope from episode 7, it removes and returns the value in one step. Here, instead of specifying a position, you just specify a key. See, पहले ये Pope हो गया 25 आ गया इसका फिर इसके बाद नेम आ गया ठीक है. Now let's move on to the next one. Pope with a default to avoid key error. Let's test this one out, then we'll see how to avoid key error. Uh, person name Sam. Removed equals first dot pop email not found. Now we'll print the removed. See, we got this not found. See, just like get and pop. Sorry, just like get pop just accepts an optional second argument as a fallback. This prevents a key error if key you are trying to remove doesn't actually exist in the dictionary. It just quietly returns your fallback instead. Now let's move to the next one. Next one is del, removing a key without capturing it. Let's check this out. Person equals name Sam, then age 25. Del person, then age. Now print person. Let's see what happened. See, इसमें पूरी एज डिलीट हो गई. We just deleted the age. See, del is a keyword, not a method. Notice there is no doubt. There is no dot before it. It just removes a key value pair entirely. But unlike pop, it doesn't hand you back the removed value to use afterward. Use del when you just simply want something gone, and pop when you need to capture what you have deleted or what you have removed. Then you can use pop. Now let's move to the next one. Next one is clear. Clear is used to empty a dictionary. Let's test this out. Person equals name Sam, age 25. Now person dot clear and print person. It will just print a empty one. See empty dictionary. See, exactly like the list version from episode 7, clear removes every key value pair, leaving behind an empty dictionary rather than deleting the variable itself. Now, let's move to the next one. Next one is set default. Now let's check this out first. Person equals name, Sam. Now age equals person dot set default age, then comma, then 18. Now just print age and print the person. See, this one's genuinely clever. Set default returns the value if they are key, if the key already exists. But if it doesn't exist, like age here, then it creates both. Then it both creates that key with your provided default and returns that same default all in a single method, all in a single method call. Okay. Now let's move to the next one. Next one is nested dictionaries. Now let's check this example first. User equals dictionary start name Sam. एड्रेस एड्रेस डाल देंगे हम डिक्शनरी को सिटी मुंबई zip now let's print user address then city. See, we got the city which was Mumbai and we got name Sam age 14 which was of here. See, we got our answer which was Mumbai. See, dictionaries can hold other dictionaries as value. This is genuinely common for representing real structured data like a user profile with a nested address. Chain the square brackets to reach all the way down into the nested value. Now let's move to the next one, which is set default get. Wait, is this the next one? No. Next one is a list of dictionaries and extremely common pattern. Let's check this out. Users equals name Sam age 25 age 25 then name Alex then age equals 30. Mm. Now for users users print user then name. Let's print this out. See what it went. Sam, Alex. See, this is generally how real-world data is structured constantly. A list of records where each individual record is a dictionary. You'll see this exact pattern everywhere once you start working with real data. API response, database, results, configuration file, all of it. Now, let's move on to the next one. So, here comes the next practice round, which is practice round two. As always, pause the video and try this out by yourself, and then you can resume the video and check the answer. So, what's the question? Question is create a dictionary for an employee with name, department, and salary. Loop over it using items and print each key value pair as a labeled sentence. Use update to give the employee a raise. Increase salary by 5,000 and change the department. Use pop to remove the department key and print what was removed. Employee equals name. Sam and department. Sales. Salary 50,000 to 50. Okay, then for key comma value in employee dot items print f string, then key then value. Now employee dot update salary 55 55,000. uh, Department marketing. Now removed equals employee dot pop, then department. Now print removed. What's the mistake in this? Wait a second. Let me just see what's the error in this. Let me check the error. Oh, this is not the error. Department marketing. Why are we getting the error? Key value salary employee dot update. Oh, it's still there. Wait. Name, department. Department was marketing. I don't know what the hell is the problem. Department. Department 5,000. Sales, then salary, then marketing. Let me just. Oh, all of this is employee.update. What's the problem in this? Okay, I got the error now. एक में ही सारा डाला था 5 1 2 3 55 1 2 3 then department is marketing. See, we got the department, we got the salary, everything is updated now. See, uh, over here, the this items, okay, items unpacks each pair cleanly, right inside the for loops header. Updates overrides both fields in a single cell rather than needing like two separate assignment lines. And pop removes and returns the department value in one step, ready to be printed or used elsewhere. Now let's move on to the next one. First, you can check the answer. See, items unpack each pair cleanly inside for loop. Update overrides both fields in a single call, and pop removes and returns the department in one step. Now, moving on to the next section. Here comes the section 3, which is dictionary comprehensions. Now, let's apply the same one-line comprehension idea from list comprehension in episode 7, but to key value pairs. Let's move on to the first one, the loop version. Let's test the loop version first. Numbers equals 1 comma 3 comma 4 squares for n in numbers squares n equals n into 2. Now let's print squares. See, we got this. See, this is the same building pattern from episode 6 and 7, but instead of appending list item, we are assigning key value pairs into an initially empty dictionary, uh, one pass at a time. We are doing this. Now let's move to the next one. Let's try the alternate one with here this logic is same, but it is in one line. Okay, let's test the code. Squares equals for n in numbers. Now print squares. See, we got the same value, but here the code is much smaller. See, curly braces instead of square brackets and key colon value instead of a single expression. But otherwise, this is the exact same shape as the list comprehension you already know from the last episode. Over here, this was the loop method, and this is the comprehension method. The comprehension method is very clean and very small. Let's move to the next one. Building a dictionary from two lists. Let's try this. Let's try this code, and we'll get to know about this. Names equals Sam, Alex, Joe. Then scores 85, comma 92, comma 78. Grade book equals n s for n, comma s in zip names, comma scores. Now we'll print the grade book. Print the grade book. See, this combines zip from so see, first of all, see the answer. This was the required answer we got. So this combines it from episode 6 with a dictionary comprehension. A genuinely elegant, compact way to turn two related parallel lists into a single meaningful lookup structure. Now let's move to the next one. Next one is filtering with a dictionary comprehension. Let's test this code and learn about filtering. Prices equals apple $2, then meat 25, then bread. See, see, affordable equals K V for K comma V in prices dot items if V is less than 12. Now print affordable. Let's run Python. See, we got apple, which is true, and bread is equal to 3. These were the affordable items in this. So we got this. See, exactly like list comprehension from episode 7, adding an if clause at the end just filters which key value pairs actually make it to the final dictionary. Okay. Only items priced under $10 get included here. Now let's move to the next one. Next one is inverting a dictionaries, which was swapping keys and values. Let's try this code. Original equals a 1 comma b 2 comma c 3. Now inverted equals v k for k comma v n original dot items. Now print inverted. Run Python. See, we got the inverted one. The key became value and value become key. See, this is a genuinely useful trick. Swap which side is the key and which is the value. Just be careful. This is only say when the original values are themselves guaranteed unique. The values must be unique. If two keys share the same value, one of them would just get silently overwritten, exactly like the duplicate key issues we saw earlier. Now, let's move on to the next one. Next one is a realistic example based on word frequency counter. Let's test this one. Text equals the cat sat on the mat. Now, words equals text dot split. Now counts equals words dot count w4 w end set of words. Now print counts. See, I just printed. See, this is one genuinely sorry. This one genuinely combines a lot of what we have learned. Split from episode 4 breaks the sentence into words. Then count from episode 7 counts each word occurrences, and set, which we are covering in full detail next, strips out the duplicate words, so we don't do the same counting work twice or thrice. Now let's move on to the next one. Next one is practice session 3. Practice round 3. Just pause the video and try this given question by yourself. Given the list, apple, kiwi, banana, fig, build a dictionary comprehension that maps each word to its length. Let's test this code. Words equals apple, kiwi, comma, banana, comma. Then we had fig. Then length equals w len of w 4w in words. Now we'll print lengths. See, we got the length. Apple 6, kiwi length is 4, banana is 6, then fig is 3. See, length of W is the value expression applied to each word, while W itself becomes the key. This one liner replaces what what would otherwise be a three-line loop with an empty dictionary, a for loop, and a manual assignment. This genuinely demonstrate why comprehensions are so popular once they click onto your mind. Now, next is first check this answer. Word equals this, length equals W colon length. For W in words, print length. See, length is the value expression applied to each word, while W itself becomes a key, a clean one-liner replacing what would otherwise be a three-line flow. Now, moving on to the next and last section of this video, which is sets. Set is an unordered collection of connected unique values. Now, let's create a set. Fruits equals apple, comma, banana, comma, cherry, print, fruits, print, type of fruits. See, we printed apple, cherry, banana, and the type of this was what set. See, curly braces again, but notice there are curly braces again, but notice without the colons that dictionary use. Just a comma separated collection of values with no keys involved at all. Python can tell the difference between set and a dictionary by whether there are colons inside the braces or there are no colons inside the braces. With the help of this Python can easily understand that. Now let's move to the next one. Next one is sets automatically remove duplicate. See, let's test this code first. Numbers equals 1, comma 2, comma 3, comma 3, comma 3, comma 4. Now print numbers. See, we only got 1, 2, 3, 4. The other threes would disappear. See, this is generally the defining feature of a set. Duplicate values are automatically dropped the instance the set is created. Every value inside a set is guaranteed to be unique, no matter how many times you try to add a duplicate. It won't print, it won't show. Now let's move to the next one. Next one is a realistic use of removing duplicates from a list. Now test this code first by yourself. Emails equals 8x.com, comma b x.com, and then a x.com. Then unique emails equals list set of emails. Now print unique emails. See, we got all of the unique emails. See, covering a list to a set, and then we are just converting a list to a set, and then just immediately back converting it back to a list. This is generally common one-line trick for deduplicating data. One important caveat The original order isn't guaranteed to be preserved through this process, so only use this when order genuinely doesn't matter to you, okay? Don't use this when you need the order. Let's move to the next one. Next one is sets have no order and no indexing. Let's try this one first. Fruits equals comma, banana, comma, cherry. देन प्रिंट करेंगे हम fruits 0. सी टाइप एरर आ गया सी. और unlike lists and tuples, sets have no concept of position at all. So there are no first or last items. So square bracket indexing simply doesn't apply here. So it will just return a type error. Now let's move to the next one. Next one is add and remove option. Now fruits equals, we already have fruits. Fruits dot add cherry. Fruits dot add cherry. Then print fruits fruits dot remove banana. Now print fruits. See, we got the answer apple and cherry. See, add inserts a single new value and remove deletes one. Notice sets use add and not append, since there are no concept of an end of a set to append onto. Add is the more accurate name of for what is actually happening over here. Now let's move to the next one. Next one is checking membership, checking if where sets genuinely shine. Let's check this. So let's check this example first. Last set equals set range 1, 2, 3, 4, 5, 6, 7. Print 5, 6, 7. In large set. Checking in on a set is dramatically faster than checking in on an equivalently large list, especially as your data grows into the thousand or millions of times. This is a genuine practice, real world reason. This is a genuine practical real world reason to reach for a set instead of list. Now let's see. Wait, why am I having this? Wait, I thought I did it. See, what is this? See, we got true as a value. Now let's move on to the next one. Next one is union. Union is used to combine two sets. It is the same as we have union in mathematics, which is also used for sets. A equals 3. B equals 3, comma 4, comma 5. Print A dot union किससे यूनिक है ना बी के साथ. Now print A or B. See, cherry apple आ गया, banana cherry apple. The hell? Okay, true आ गया. उसके बाद आया right. Print A and B. See, union combines every unique value from both sets together. Notice three appears in both A and B, but it only shows up once in the result. Sets never like allow duplicates, even ones created by combining two sets together. The symbol is shorthand operator for exact same operand operation. Let's move to the next one. Next one is intersection. Values, the same values in both of the sides is known as intersection. Let's test the code. A equals 1, comma 2, comma 3. B equals uh, 3, comma 4, comma 5. Print A dot intersection of B. Print A and B. Wait, I have to just. Yeah, we got the answer. See, 3 and what we got? 3 and 3 is the answer of this. Intersection. इंटरसेक्शन क्या होगी इन दोनों की? 3 होगी क्योंकि 3 इन 3 दोनों में 3 तो 3 ही आएगा. सी, intersection finds only the value present in both sets simultaneously. Here only 3 satisfied that condition. Genuinely useful and anytime you need to find what two collections have in common. Now let's move to the next one. Next one is difference. Values in one but not the other. Let's try this one. A equals 1, comma 2, comma 3. B equals comma 4, comma 5. Now print A dot difference of B. Now print A minus B. A minus B. Both will be same. Both will give the same output. Wait, let it be. Let it load. See, we got 1, comma 2 and 1, comma 2 on both of them. See, difference finds what's in but specifically not in B. Okay, difference finds what's in A but specifically not in B. Order matters a lot over here. Unlike the union and intersection, A to difference B and B to difference A would give you two completely different results. So the deliberate so so be deliberate about what uh, which set means comes first. Let's move to the next one. Next one is a realistic example based on comparing two groups. Let's test this one. Tents math equals Sam Alex Joe students science equals Alex and Dana. Wait. Now, both equals students underscore math and students and students underscore science. Now we have to print both. See what we got. See, in one we got Alex, we got Alex in this one. Print both में Alex मिला क्योंकि इन दोनों का Alex ही आता. See, this is a genuinely practical use case for finding which students are enrolled in both classes using set intersection instead of writing a manual nested loop to compare every name against every other name. Mm, this is both shorter to write and per what we just covered, genuinely faster to run. Let's move to the next one. Next one is set comprehensions. Let's try this one. Numbers equals 1, comma 2, comma 2, comma 3, comma 4, comma 4, comma 5. Unique squares equals n 2, 4, and in numbers. Now let's print unique squares. See, we got that 1, 4, 9, 16, and 25. We got all the squares. See, curly braces without a colon, exactly just it exactly like creating a set directly, okay? This is the set version of the comprehension pattern we have now seen applied to lists, dictionary, and now sets. Now let's move to the next one. Next one is the practice round 4. Just pause the video and try this. Given is two list of ingredients for two recipes, convert both to sets. Find which ingredients are needed for both recipes. Find which ingredients are only needed for the first recipe. Recipe A, recipe B. Uh, Now let's just try this one out. Recipe A equals flour, 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 sugar, comma eggs. Recipe B equals flour, eggs, comma milk. Now shared equals recipe A and recipe B. Now let's print the shared one. Shared and only on A equals recipe of A minus recipe of B. No, print only A. See, what happens here? See, uh, this and finds the shared ingredients between both of the recipes, which were flour and eggs are needed in each, and finds what's unique to recipe A, specifically sugar and butter, and don't appear in recipe B, but at recipe B at all. Generally, practical set opportunities apply to a real, relatable scenario. Now, let's check the answer. See, the same answer. Now, let's move to the next one. This is the main challenge of today's video. Just pause the video and try this out. This combines everything from today into one final challenge. Uh, Pause the video and attempt this fully before watching the solution. Okay. Build a simple contact deduplication tool. Start with a list of contact dictionaries, some with duplicate emails. Use a dictionary comprehension keyed by email to automatically keep only the last entry per email. Use len to report how many duplicates are removed. Print the final unique contact list using items. Now let's try this out. Let's try this one. Contacts. X.com, comma, name, Sam. Sam. Let's just copy this. Wait a second. Control V and then Sam. Now unique equals C email C for C in contacts removed equals length of contacts minus length of unique. Now let's print using f string. Okay. Duplicate duplicates, uh, remove, removed. Now we'll write for email, comma, contact in unique dot items. Now we'll print email, comma, contact. Contact के बाद डालना है नेम हमें. Let's see the answer. See, first, just let's just trace through this. The dictionary comprehension builds a new dictionary keyed by each contact email. Since a@x.com appears twice, the second entry, SAMT, naturally overrides the first one. Exactly the same duplicate key behavior we saw right at the start of today's episode. Uh, just now being used deliberately as a feature instead of encounter as a surprise. Length of contacts minus length of unique tells us exactly one duplicate was removed, and items at the end unpacks the final cleaned up contact list. This genuinely uses nearly every major concept from today's dictionary comprehension: key uniqueness, length, and items. Now let's move on to the next one. First, let's just see the answer. Contacts is unique is equal to C email C for C contacts. The mode is equal to length context C same. Uh, a dictionary comprehension keyed by email deducts later entries naturally override earlier ones. Length compare before and after counts items unpacks the final result cleanly. Now let's move to the next one. Next one is episode 8 recap. Let's recap everything we have covered today. We covered dictionaries, which included key value pairs, safely accessing key value with get, and mutability. We covered the full dictionary method toolbox, which had keys, values, items, update, pop, delete, care, clear, and set default. We covered dictionary comprehensions, the same one line pattern from list comprehension now applied to key value pairs, including filtering and inverting. And we covered sets, which were guaranteed unique, unordered collections, along with union, intersection, difference, and set comprehensions. Now, in episode 9, we are covering functions. In function, we'll cover default, then arguments, then return values, scope, and lambda function. This is genuinely a point episode. Every single piece of code we have written so far lived directly in one long script, top to bottom. Functions are how you start organizing code into clean, reusable, named pieces. It is genuinely the foundation of writing real, larger program instead of just longer and longer script. Hit the subscribe so you don't miss it. See you in the next episode, episode 9. Bye bye.